Dear learners, School of Engineering and Technology, Indira Gandhi National Open University welcomes you. Today, we are going to discuss in the topic of Introduction to Nanotechnology and its various applications. Before entering the topic, we should know what is nanotechnology, why it is so important, how its place in various sectors. So all those things we have to cover, and apart from that, it's what are the various applications from till date. Why should we go for nanotechnology? What is the need of nanotechnology? Basically, the nanotechnology plays an important role in the development of the country, not only the development of the country, also in that impact up in the various fields such as teaching, research, and various industrial sectors. Nanotechnology is recognized strong innovation driver and strategic technology for the world future economy. Why should we go for nanotechnology? What are the basic needs? Basically, it leads economic growth of individual as well as the nations. It enhances the national security in terms of defense. So, the various defense equipments, sensors, drones, so many the various defense equipments to enhance the national security. Improve the quality of life in food sectors, medicine, in so many sectors, the nanotechnology plays an important role. So, it improve the quality of the life. It creates a lot of employment opportunities across the world in various type of industries. Also, it provides very safe and clean environment for the people. It's also improve the fuel economy, improve the performance. At the same time, it's reduce the emissions. It also its body structure weight reductions. It's very small, simple, and cost effective. As per the forecast of the National Science Foundation estimates, by the year 2030, almost 3 million workers are required throughout the worldwide in the field of nanoscience and nanotechnology. In addition to that, 6 million workers also needed in the support areas of nanotechnology. By the 2050, expected that almost 6 trillion industry may establish in the across the world. Basically, where it starts, how it's originated. Basically, the Richard Feynman, we first conceived the idea, the molecular manufacturing, through his speech in the year of 1959. That there is a plenty of atom at the, there is a plenty of room at the bottom. That means that there are a lot of opportunities available in the below the atomic level, which is able to manipulate individual atoms and molecules. After that, Professor Nariyav Taniguchi, Tokyo Science University, described the machining with tolerance at nano level in the year of 1974. Generally, basically, it's first properly coined by Dr. Erich Drexler through his article, The Creation of Nano Engines, in the year of 1986 at a Defense Research Laboratory in US. The terms, the creation of nano engines refers that the manifestation of matter at nanometer scale. What is nanotechnology? Nanotechnology is basically the creation of useful and functional materials, devices, systems through the manipulation of individual atoms at molecular, at atomic nanoscales. Nanotechnology is basically dealing with the synthesis, strategy, and manipulation of particle ranging which is from 1 to 100 nanometers. Basically, it's an interdisciplinary field where science and engineering is interconnect. Nanoscience is basically deals with the property of materials, which is 1 to 100 nanometers. But nanotechnology deals with the developing of new products and new methods, which is used for, which is converted nanostructures into useful tools and applications. That's the difference between nanoscience and nanotechnology. Now, science deals with only the property of materials, which is 1 to 100 nanometers. This is called the nanostructures. But technology deals with the applications based. There are a lot of research and development is ongoing in nanotechnology. The research and technology development at atomic and molecular scale, that should be its 1 to 100 nanometer range. Also, that technology development at the atomic molecular scale to 1 to 100 nanometers, which is create structures, devices, and systems have novel properties. Also, it's used in detection and diagnosis of disease and COVID-19 also. What is nanoscale? Nanoscale is an important parameter which is used to describe the size of nanotechnology, which is 1 to 100 nanometers. Basically, the 1 nanometer is the 1 billionth or 10 power minus 9 of meters. For example, the single particle of cigarette smoke, it's about to 10,000 nanometers. Average width of human hair, it's about 75,000 to 1 lakh nanometers. These charts represent the Hitchhiker's nanochart. See that the chart where that human, it's approximately 1.75 meter. It's called that macrovolt. Then it comes to that fly, it's 1 centimeters. Then hair diameter is about 75,000 nanometers. Then its limits of phi is 10,000 nanometers. In microelectronic MEMS, it's about 10 to minus 4 to 10 power minus 6 nanometers. Then it's E cell bacteria 2000 nanometers. This is called that microworld. Then it's come to the nanoworld. Its nanoshell, it's 100 nanometers. DNA width is 2 nanometers. Carbon nanotube is 1.3 nanometers. The buckyball is 1 nanometers. So that's it's transfer from the microworld to the nanoworld. How the size deformation takes place in the Hitchhiker charts from that 1.75 nanometer to the 1.75 meter to the 1 nanometers. This is another chart which is represent that decimeter to pictometers. So then it travels from that decimeters, then centimeters, then millimeters, then micrometers. After that, it's nanometers. In future, it's picometers. It's a 10 power minus 12 meters. One pictometer is about 10 power minus 12 meters. Is a future technology. In this nanotechnology, we have the two different types of approach. One is the top-down approach, another one is the bottom-up approach. For example, that it's aircraft carrier, it's about 1 kilometer length. Normal human beings is 1 to 2 meters. Then size reducing that butterfly, it's 1 mm. In biological cell, it's 1 micron meter. Similarly, it's come to DNA cell, it's 1 nanometer. So it's vary from 1 kilometer to 1 nanometers. Why should we prefer nanotechnology? What is the reason to make it miniatures? What are the reasons to make it small? So reason behind that, once it's make it miniature in small at nano level, it should become very faster and lighter, cheaper, limited resources, can get you into small spaces, so the area may be economical and energy efficient, so easy to handle and develop unique properties at small scale. Disposable, avoid contamination. So its environment makes environment friendly. The size of that nano molecules, that's water molecules is 3 atoms. The protein molecules, it's about thousands of atoms. The DNA molecules is about the millions of atoms. But nanowires and carbon nanotubes is about that 100 nanometers. Nano-sized particles. There are different sizes of nanomaterials are available in the society, such as that nanoparticles, it may be the spherical or capsule shapes. The nanocomposites, then in the available in materials in different forms, such as nanofluids, nanofilms, nanoshells, nanowires, nanobeads, nanochips, nanocones, nanocrystals, nanofilters, nanocontainers, nanodots, and quantum dots. These are the various shapes and size of the materials which is available in the industry. These nanostructures, basically it's classified 2D structures, 1D structures and 0D structures. So 2D structures are thin films, Quantum belts, superlattice it comes under 2D structures, and 1D structures is nanowires, quantum wires, nanorods, and nanotubes are in one-dimensional structures. Zero-dimensional structures are nanoparticles and quantum dots. These are the figure shows for the example of this thin film and multi-wall carbon nanotubes. Nano shell is basically the composed silica core surrounded by the cold coating, which is about 100 nanometers. Quantum dot is a semiconductor nanocrystal, which is 5 nanometers. Carbon nanotubes is about 1.3 nanometers. Buckyball is a saucer ball shaped molecule made of 60 carbon atoms. So the corresponding images are given. What is the basic process of nano manufacturing? These are the basic concepts of nano manufacturing. Basically, the preparation of tip preparation of the atoms, then it makes it workpiece preparations, then its position, atomic position has been controlled, then we can get the final product. This is a basic concept of this nano manufacturing. Basically, the nano manufacturing is the process of producing nanomaterials, either which can be powder or fluids or solids at nanoscale, which is 1 to 100 nanometers. Basically, the bulk material is subsequently refined into small pieces or small materials, or individual atoms and molecules build upward to make at nanoscale materials. These are the two types of approaches. One is a top-down approach, that is bulk material is subsequently refined into small pieces. That's called top-down approach. Or individual atoms and molecules build upward to make at nanoscales. That is the bottom-up approach. So top-down fabrications start with a large material and bring into nanostructures. That's called that macro to nano. See the figures. The bulk materials make it into powders, then it comes into nanoparticles. That is top-down approach. Similarly, for in bottom-up, atoms and clusters make it into clusters, and the clusters make it into the nanoparticle. So it starts with the individual atoms and molecules, build upwards to make your nanostructures at nanoscales. This is quantum to nano. So top-down approach can define that approach where they are synthesized or constructed by removing the existing material from larger entities. That larger entities, from the larger entities, that bulk material can be synthesized into small materials, small parts, small pieces. That is called the top-down approach. Similarly, for the nano objects are constructed from entities without atomic level control. That's the more important. In top-down approach, there is no atomic level control is the place here. Similarly, for every product begins with the bulk materials process subsequently refined down. So every bulk material process is subsequently refined into small pieces or small particles. That's called top-down approach. See the bottom-up approach. Bottom-up approach, the material and devices built atom by atoms. Materials and devices built from the molecular level of components which assemble themselves chemically by principle of molecular recognitions. The fabrication of device structures via systematic assembly of atoms, molecules, or any other atomic units of matter which can be enhanced into that nanoscale. That is the bottom-up approach. See that figure as given for the bottom-up approach. This approach is much cheaper. This becomes much larger. Example of molecules self-assembly or is a Greek base appearing at the nanolithography is one of the example of bottom-up approach. So they have two different methods: top-down method and bottom-up approach. Top-down approach is vary from bulk to nano. Similarly, for bottom-up, quantum to nano. So that top-down approach methods are this mechanical grinding. That is a large scale materials that can be grinded into nanoscale, small piece of materials. That is one is called mechanical grinding. Another technique is a lithography. The tiny chips from relatively large structure that can be synthesized into small particles. That is another methods. In bottom-up approach concern that self-assembly, that the desired nanostructures are self-assembled without the atomic control and are external manipulations that can be synthesized into the nanoscale. Another method of bottom-up approach is that position assembly. Here also we can manipulate the atom and molecule without atomic level control. There are various synthesis techniques for that nanomaterials. For gas phase methods such as vapor evaporation and condensation methods, chemical vapor deposition methods, and laser ablation methods. These are the gas-based methods. Another is the chemical methods. So, chemical method which consists of precipitations, microemulsion synthesis, salt gel synthesis. Salt gel synthesis is normally used for manufacturing nanomaterials, and spray drying and spray pyrolysis and thermal decompositions. Mechanical deformation concerns that mechanical alloying, the chemomechanical alloying, and severe mechanical deformations. There are various mechanical deformations methods are available for making nanomaterials. But what is the difference between top-down approach and bottom-up approach? This is a major important. It's a bottom-up approach. Basically, it's quantum to nano. Similarly, it's top-down approach, bulk to nano. Bottom-up, it can be found from the nature, but in top-down, it cannot be found from the nature. But bottom-up having the high precision accuracy comparatively, but top-down is the less precision accuracy. But bottom-up approach, there is no wastage of materials because it's started from lower level, the small to bigger size. But in top-down approach, we are reducing the material from bulk size to small size, so wastage of materials is possible. There are various nanofabrication techniques in top-down, such as electron beam lithography, dip pen lithography, nano imprint lithography, UV imprint and UUV lithography, laser ablation and etching lithographies. These are the techniques which are used for in top-down approach for making the nanomaterials. Similarly, for bottom-up approach, there are three methods such as chemical synthesis, self-assembly, and positional assembly. These are the three methods which is used for that bottom-up approaches to making the nanomaterials. So, top-down lithography, how it's functioning that, how that it can be, bulk materials can be synthesized into small materials. How the bulk material can be gradually removed into the small materials. So, see that figures, the film depositions, either CVD or PVD, whatever that materials deposited in the film, it can be subtracted by using the photoresistance applications. It can be using that photoresistance of light and mask. The exposure takes place. The etch mask can be removed. Etching will take place. Finally, remove the material that remove the materials. Then finally, we can get that nanomaterials. Similarly, for bottom-up positional control will allow the atoms to be placed precisely without spots pumping into each other. That means that without atomic level controls. These are the Drexler robotic arm, also used for the bottom-up positional control. Similarly, for robotic arm to control the placement of atoms, the Stewart platform, which is stiffer and simpler than Drexler robotic arm. So, this is a general procedure for development of nanomaterials. We should understand the fundamental of understanding. Then we have to make the modeling and simulations. And similarly, for characterization experimentation, finally we can synthesize and integrate into the nanomaterials. So, nano to macro, inorganic and organic. So, optical with mechanical with electrical and magnetic and all applications can be synthesized in the nanomaterials. What is nanocomposite materials? There are the two or more materials are made of distinctly and dissimilar materials such as mixed and synthesized and characterized at nanoscales. That is called that nanocomposite materials. The two or more materials are made of distinctly and dissimilar components and mixed, synthesized and characterized at nanoscales. It produces the final outcome of this process. We can get that new material which possesses superior properties than any other materials, which average grain size should be less than 100 nanometers. See the figures show that nanoparticles and the matrix material, how can get that nanomaterials. There are various methods to produce a nanomaterials such as sol gel process, unit gas concentrations, mechanical. So nanotechnology is basically important, plays an important role in various industries, teaching and research sectors. Apart from that, it plays various application in different type of industries such as textile, medicine. So, nanotechnology is important techniques which is developing the new nanomaterials such as sol gel process, inert gas concentration, mechanical grinding, mechanical alloying or high energy ball milling, plasma synthesis and electro depositions. There are methods to produce nanopowders such as rapid expansion of supercritical fluids, particle from gas saturated solutions, depreciation of expanded liquid organic solutions. This chart indicates that this flow chart indicates that how to produce the nanomaterials. What is the method of fabricating the new nanomaterials? So basically, there are the basic requirements of nanomaterials to make the nanopolymer composites. There are acetyl pyridinium bromide plus water plus clay particles that can be mixed vigorously for 24 hours at room temperatures. Separate and then it's separate into clay particles and keep it dry for 48 hours. Add the purified acrylic such as monomer. Then it's the polymer resin and the clay dry particles that can be mixed together and keep it for dry for 48 hours. So then add the polymerization initiator, that means that benzyl peroxide, then it's mixed stirred vigorously, then it can be heated up to 80 degrees centigrade about 1 hour, then it's cool up to that 40 degrees centigrade, add the hydrogen hydride to making the hardness of the materials, then pour into that mold cavity and allow to curing for 1 month durations. Finally, we can get that formation of nanocomposites. So that nanocomposites makes that final stages of nanocomposites that can be tested in that ASTM standards. What we can measure in the nanomaterials? Once that based on that methods, we can produce that nanomaterials through the mechanical. This is the method is called that mechanical grinding methods. These are one of the nanopolymer composites manufacturing methods. Basically, that acetyl pyridinium bromide plus water and clay particle that can be mixed in that ratio by ratio. The clay particle that can be stirred vigorously for 24 hours room temperature. Then separately clay particles keep it for dry for 48 hours. Then the dry clay particles and polymer resin add with the polymer resin. Then add that purified acrylic for the monomer. Similarly, add the polymerization initiator as a benzyl peroxide. Then it's mixed integrally, stirred and vigorously. Then the same clay particle and resins can be heated up to 80 degrees centigrade about 1 hour. Then it's cooled up to 40 degrees centigrade. Then after cooling that, add the hydrogen hydride as a hardener. Then it poured into the cavity, allowed in the different size required cavity to curing for 1 month durations. Then final the nanomaterials, the formation takes place. The formation of nanocomposites will go for that testings, various types of testings, wherever it's required. What we can measure? So, what are the parameters we can measure in the nanomaterials? There are that structures based measurements. the crystallinity, crystal structures, strain, defects, surface roughness. Similarly, for composition measurements, atomic species, concentration, diffusion, and segregations. The properties concerned, there are various properties such as magnetic, electrical, optical, and mechanical, and thermal. So, magnetic concern that susceptibility and magnetoresistance, electrical concern that Seebeck coefficient, carrier density, electron states, band gap, dielectric constant, and conductivity. Mechanical concern that yield, strength, tensile strength, hardness, failure, various types of failures, stiffness, modulus of elasticity. Thermal concern that conductivity and specific heat. These are the measurements we can test for the nanomaterials. There are various tools and equipments used for synthesis and characterization of nanomaterials, such as scanning electron microscope, transmission electron microscope, atomic force microscope, scanning transmission electron microscope, reflection electron microscope, scanning tunneling microscope, X-ray diffraction, and UV spectroscopy. Scanning electron microscope, how it works? What is the outcome of the scanning electron microscopy? Instead of light, the SEM uses the electron beam to see the 3D images. Mainly that's to determine the particle size and distribution of the object, to examine the fracture surface. Here it's the electronic gun emits the high energy electrons. High electron beam is passing through the anode. Then it's focusing via magnetic lenses. Scanning coils move beam across the sample. Specimen placed in the bottom of the stage. Then it's passing through the back scattered electron detectors. Finally, the secondary electron detector, the surface topography available in the specimen. Surface topography of the specimen. It is about the resolution about 5 nanometers. That can be detected through the electron detectors. This is the outcome image of the nanomaterials. This is the image of nanowires and nanocomposites. Next, the atomic force microscopy. This is a basic atomic microscopy, the detector and laser and cantilever beam, the mirror and tip, the sample. Sample placed in the bottom, the mirror placed in the with the self of tip. When the laser passes the electron beam, it reflects in the mirror from the detectors. So, by using the detectors to detect the resolution of the samples, so that height of the prop we can keep the force of the sample constant. So, imagine measuring the manipulation of the object, it creates the 3D images. So, resolution is approximately up to 0.1 nanometer and lateral and vertically in 0.02 nanometers. These are atomic force microscopes images for the carbon nanowires. How that atomic force microscope making the images. Next, the transmission electron microscope. Use high energy electron beam to probe material with thickness less than 100 nanometers. Here it's a high energy electron beam to use to probe the materials, and some electrons are absorbed bounds of object, some pass through the object. Some of the electrons is absorbed or some of them passing through the objects, and it makes a magnified the images. So, digital camera which records the images of the materials. Next, scanning tunneling microscope. The use of nano-sized probe to scan the objects and materials. Uses of tunneling to detect surface and create the map surface. Rate of electrons tunnel from the probe to surface related to distance between the probe and surface. The rate of electrons tunnel from surface, it should be related to the distance between the probe and surface. Next, there are different types of investigation: structural investigation, thermal investigation. So, the thermal investigation concerns that using that differential scanning calorimetry, which is used to study the phase transition and glass transition temperature of the materials. Also used to study the melting, crystallization and curing temperature of materials. And thermochrometry, differential thermoanalysis and differential thermochrometry analysis, which is used to study the temperature of difference and mass difference. Also study the changes in polymer decomposition temperature between the various samples. Also used to study the thickness of polymer layer surrounding the nanoparticles. Structural investigation concerns that it's found the superior mechanical properties when compared to that simple composites by using the various mechanical and structural testings and analysis. There are various structural testing such as tensile, compression and hardness. So many tests and structural investigations takes place. Mechanical and structural characterization can be done using tensile testing and dynamical mechanical testings and nano-indentations. This figure shows that tensile testing, that the images show the outcome of the tensile testings. Show that basically the characterization of nanomaterials is most important in the nanomaterials. Mainly its main characteristics of nanomaterials are it's reduce the weight. So once it's reduced the weight, automatically that tensile strength will be increased. So it's become very strong and hard. Also increase in the operating temperatures. Ductile at high temperatures. It provides the ductility at high temperatures. Ultimately, that once the weight is reduced, the strength is increased, automatically the efficiency will be enhanced, strength will be improved. So it provides a better wear resistance, also provides thermal and dimensional stability. So there is resistance in the chemical as well as that corrosions. So antimicrobial activities takes place. Totally it's pollution free. There are different advantages by using the nanotechnology. One of the medical advantages, the targeted therapies. Normally that nanomedicines for deliver the precise drug delivery in terms of our cancer and heart diseases. Mainly that it kills that cancer cells by using the nanomedicines. Also it reduce the side effect of the cancer. It's also a nanomedicine used to detect the early diseases by using the nanosensors and nanopores, which helps to detect the early disease in the previous stage. So the person can be saved. And also that cure the universal immunities such as AIDS, flu and so on. So advanced diagnostics can be done through nanomedicines. That body sculpturing, that nanomedicines can be used for the body sculpturing, the change of physical appearance. Also that aging process makes slow and childbirth can be painless. An industrial and social advantages concern that self-assembling the computer goods. So computer billions faster and million times smaller. So automatic pollution cleanup, so that environment should be clean and environment friendly. So manufacturing will take place at low cost. So economy should be reduced. So molecular food synthesis, so that molecular food synthesis take place. So end of global starvation. Superior in educations. So reintroduction of extinct animals and plants. Dinosaur can be possible to reintroduced. Terraforming Earth and other planets can be studied. Inexpensive and safe travel. The safe travel, space travel should be safe and inexpensive. There are various basic requirements of nanomaterials, such as it should be in lightweight, high strength, high toughness, corrosion resistance, easy repairability, reusability, less maintenance, durability and low cost. There are various applications of nanomaterials. Generally, nanomaterials can be used for the different application in almost in all sectors: aircraft, space, defense, marine, food and agriculture, chemical, automobile, electrical and electronics, medical and biomedical, optical, structural, recreations and cosmetics. So aircraft concerns that it should be weight should be reduced, simultaneously strength should be increased. So that airframe structures in the aircraft, the various parts of aircraft can be made up of by nanomaterials, such as aircraft structures, aero engine ports, aircraft electro-communication system. These are that made by nanomaterials. Similar to the space sectors such as nanosensor, nanorobots, nanolaser sails, nanorovers, space suits, and space foods also is manufactured using through the nanomaterials. Similarly, for use in marine and automobiles, marine concern that it's marine vessels, marine hull, shipbuilding, ship surface coating, smart ships also manufactured by using the nanomaterials and nanotechnologies. In automobile concern that the body of automobile vehicles, chassis of the vehicle, and automobile engines, windows and wipers of vehicles, wheels and tires of the vehicles, and automotive cooling. This all it's enhanced by the nanomaterials. Nano coating is concerned that it's self-cleaning. It's automatically is cleaned by itself. It's easy to clean. The clarity should be, optical clarity should be visible. Improve the smoothness. Heat resistance is resist from the heat. So temperature, absorb the temperatures. Similarly for corrosion resistance, resist the corrosions. By using the nano coating, there is no need of water and other cleaning agents. So that it's reduce the usage of water and cleaning agents. Basically, that nano coating is even this is the one figure shows that the international Pune International Airport, they completely using the nano coatings. So it won't nano coating is it won't absorb the dust particles, rather it's remove the dust particle from there itself. It won't absorb that dust particles. So it's automatically fall down from the wall or surface. In defense concern that its nano materials can use in different applications, which is for nano sensor, which is used for detect the biological agents and weapons wherever it's invisible. Similarly, in nano radars can be used the nanomaterials to detect, and unmanned air vehicles such as drones, nanotechnology can be used, and GPS and nano helmets which protect the from the gunshot. Similarly, for jackets and smart uniforms that should be durable and bulletproof, protect from high temperatures, high impacts, and chemicals and dangerous chemicals. It can be protect from all those things, the nanomaterials. It can be used in the defense sectors. Similarly, for in food and agriculture sectors, in food sectors that there is a nanotechnology can be used for the preservation of food without refrigerations. It's protect from bacteria and various diseases. So it should be light and safe foods. In agriculture concern that it enhances the productivity through the precision farming. By using the nanotechnology, we can increase the productivity of the agriculture products. So it can be used to identify and control and cure of crop diseases. So crop diseases can be controlled and cured. The pesticides and fertilizers of our crop growth by using the nanotechnology. So ultimately, that the crop productivity can be increased and disease can be controlled. The test and monitor condition of soil can be possible by using the nanotechnology. The soil testings and monitoring can be possible. And also is another important to reduce the agriculture waste, that is the keep environment clean. So that major issues happening in Punjab in Haryana, there are the disposal of agriculture waste. So that is the major issues in the nation. So that in nanotechnology helps to reduce the agriculture waste and keep the environmental clean. So medicine concerns that nanomedicine is a medical application of nanotechnology and improve the diagnostics, treatment and prevention of disease, mainly for its AIDS and cancer treatment. So its nanomedicines can kill the cancer cells. Also, it's reduce the side effect of the cancer diseases. So that similarly for various bone treatment, drug delivery, appetite control, drug development, medical tools and diagnostic test and various imaging applications can be used in the nanomedicines. In IT sectors, we know that how that nanotechnology can play the important role in the information technology. So it makes smaller, faster, more energy efficient and powerful computing and ultra high density memory. So carbon nanotubes can replace the silicon transistor. So conventionally we can use the silicon transistor. Now that by using the carbon nanotubes can be replaced with silicon transistor, so that efficiency can be enhanced, the faster and speed, cost also should be reduced. So nanorods also used is the display techniques due to less consumption in electricity and less heat emissions in IT sectors. Size of a microprocessor reduced to greater extent, so that by using the microprocessor size can be reduced by using the nanotechnology. So nano dots, quantum computing, medical imaging, printing and spin coating, that all these applications the nanotechnology plays a crucial role. So energy sector is concerned that it's generating the steam from sunlight by using the nano solar device, steam device, which helps to generate the steam from the sunlight. So high efficiency light bulbs by using the nano plasmonic device, increase the electricity generation by windmills by using the nano windmill blade, generate the electricity from waste heat by using nano tube sheets, storing the hydrogen for fuel cell empowered cars, nano graphite layers, reduce the power loss and friction to reduce the energy consumption by using the carbon nanotubes. So ultimately that energy efficiency can be improved and cost of the fuel should be reduced. Thin film application concern that solid fuel cells, thin film solid electrolytes and electrodes with the high conductance. Thin film transistor is liquid crystal displays, require high mobility and flexible substrates. So gas sensing applications show thin layers in electronic devices. These are the various thin film applications. So nanowires concern that nanowires can be help in nanotechnology in different sectors, such as that field effect transistors, thermoelectric materials, LED light emitting diodes, detectors, sensors, nanolasers, superlattice nanowires in application of requiring superlattices. These are that various application of nanowires. That carbon, initially we use that aluminum for then later than we use the copper. Now that carbon nanotubes replaced to in that conductivity of the electricity. So it show that a very low electrical resistivity by using the carbon nanotubes. So crime detection concerns that nanotechnology plays an important role to detect the various crimes. For narcotic examinations, the nanotechnology can play the important role, and fingerprint analysis of suspected crimes, and DNA testings and sequencing analysis and forensic investigations. The drug identifications is a various types of drug that can be identified by using the nanotechnology. The various crime documents can be examined by using the nanotechnology, and that various evidence of the crime evidence can be analyzed and traced by using the nanotechnology. And CCTV and ultra unmanned air vehicle systems, security systems can be used by using nanotechnology. So nanotechnology plays an important role in CCTV as well as drones in other unmanned air vehicle systems. Also, it helps to detect and diffuse the explosive. So, explosive can be easily detected as well as diffused. So, consumer concern that we know that all food and beverage, appliances and textiles, household and sports cosmetics can be used by using the nanotechnology. So, the food packing materials, sensors, lab on chips for food quality testing. Quality testing of food testing can be using nanotechnology. Similarly, for appliance and textiles, it should be provides the stain-proof, waterproof, and wrinkle-free textile products. And household and sports and cosmetics concerns that it helps self-cleaning and scratch-free products, better appearance and good aesthetics of household and sports and cosmetics items. So, every technology having some drawbacks. So, similarly in the nanotechnology having also some pitfalls, such as that ultra-fine particles can catalyze chemical reaction in the body. So, carbon nanotubes can cause infection of lungs. So, the clash of blood-brain barrier can take place by using nanotechnology. Damage of the cell can take place. Oil and diamond becomes worthless. Atomic weapons more accessible and destructive. So, nano liquid bombs also it's available in that for destructive purpose. So, it can provide a psychological fear. So, fear of grey goo. These are some various drawbacks of nanotechnology. So, conclusion that nanotechnology basically it's concluded that it when be drawn into the nanocomposite material show much improved properties over micro-similar systems. Nanocomposite material concerned that it's much improved properties when compared to the macro properties, macro level materials. So, compared to that nanocomposite material compared to that macro level materials, ultimately it should be enhanced and high strength. It's provided the high strength. There are, because of smaller size, the nanoparticles have high surface volume ratio, and also it's provide the high energy surfaces. So, the experimental data has shown that it reduce the particle size, improve the various properties, especially the elastic modulus. So, it increases the confidence in the use of nanocomposite materials in safety critical components and service applications. By using the nanomaterials, ultimately it increases the confidence of using the nanocomposite materials, and also in various safety critical components and service applications. So, there are different safety critical components and service applications. The nanotechnology can play the important role and provides the confidence. Reduction of test program cost. So, for testing the various products, it can be cost should be increased, but here it's nanotechnology concerns the test program cost is reduced. Also, the time scale by optimizing testing and analysis. So, the time scale by also it's reduced by optimizing the testing analysis. Ultimately, the cost of testing should be reduced and time should be reduced. So, improve the confidence in design factors and increase the efficiency by using the nanomaterials. By using the nanomaterials, the confidence of design factors is increased. Similarly, for efficiency also increased. Nanomaterial development it's felicitate to increase the flexibility in design of new products at least manufacturing cost. There are recent developments in the nanotechnology. The solar rods, which is able to make solar cells strong enough to surface rods. So, nanotechnology could make LCDs brighter, thinner and cheaper. So, nanopolarized could significantly enhance the contrast ratio in liquid crystals. Networks of carbon tubes enable numerous basic electronic functions at low cost. So, example e-paper, flexible e-touch screens, sensor, etc. The figure shows that the e-paper and this flexible touch e-screens, sensors and so on. There are recent developments raised in this nanotechnology world. The nanopolicing paste. The policing paste containing the nanomaterials can be used to reduce the roughness of the surface up to 0.9 nanometers. So it's another type of nano coating technology. The policing is a type of paste which containing the nanomaterials, which is used to reduce the roughness of the surface, approximately up to its 0.9 nanometers. This is the use of nanopolicing paste. Similarly, for fuel nano additive technology, this is another recent development. Nano graphite based motor oil additives, which is used to reduce the fuel consumption up to the 12%. Also, it's reduced the friction and wear. These are another important developments in the nanotechnology. So currently, there are various research on progress, such as the washing machine inbuilt that inhibits the bacterial growth on the clothes while doing the washing. So whenever doing the washing of the clothes, that machine itself detects the bacteria in the clothes. So it can be detected and can be destroyed. Similarly, for contact lens, that will check your blood sugar level by looking in a mirror. By using that contact lens while checking the blood sugar, when you are looking the mirror, whenever they looking the mirror using that contact lens, that sugar level can be indicated. Similarly, for intelligent nano coating, for windows that reflect of solar heat in the summer, and similarly for transmit into winter. This is the effective of intelligent nano coating for especially for the windows. Automobile fuel lines made the carbon nanotubes inhibit static electrically and reduce the risk of explosions. So that there are a lot of accidents happening in that vehicle fire in that public while traveling. So in that automatic fuel lines made with the carbon we're using the carbon nanotubes, the explosions fire can be reduced in the vehicles. So there are a lot of employment opportunities in different fields in the nanotechnology, such as design and research and development area. There are research and development, lot of huge employment opportunities in that research and development of various sectors, as well as design sectors and manufacturing of various products and maintenance sectors. Similarly, for teaching and training sectors and transport and service sectors, agriculture and environment sectors, national security and public service, technical support and patent attorney, testing and quality assurance, construction and maintenance, sales, marketing and management, fabrication and packaging. So that nanotechnologies provide the various employment opportunities across the world in different sectors, different industrial sectors, not only that industrial sector as well as service sectors. So it provides a lot of employment opportunities in the worldwide. There are some important reference books and materials for that to learn about nanotechnology, such as that the essentials, that's authored by Pradeep T. The publications Tata McGraw-Hill Publishing Company Limited. Similarly, for nanotechnology, authored by Richard Booker and Early Bison. Nanotechnology by Billy Publications. And nanotechnology is Mansi Karkare. Its fundamentals, nanotechnology fundamental applications is published by IK International Publications. These are the two important books for that nanomaterials, which can be used to understand the basic concepts. Learners, today we have covered that what is nanotechnology, where it can be used, how it can be developed, what are the basic and fundamental concepts, and how what are the basic technologies can be used for that developing and manufacturing nanomaterials, how that nanomaterials can be produced by using that mechanical manufacturing methods, and what are the various characteristics of nanomaterials, and what are the various what are the property requirements of nanomaterials, and what are the various applications of nanomaterials across the world, and what are the various employment opportunities in the world. So these are the things we have covered today lectures. In further lectures, we can go through on in depth of the nanotechnology. So learners, today we have discussed the introduction to the nanotechnology and its various basic applications in the industries and societies. Learners, thanks for your passion listening.